Hello again. We're going to talk about magnetic fields. Where can you see? You can see here, right. I've had to make the camera quite... Oh no, you still can't really see that. Quite close to the paper so you can see this one. So I'm going to talk about the shape of a magnetic field, or how you can find the shape of a magnetic field, because you can't actually see it with your own eyes, because it's not, it's not something you can reach out, you can touch, you can feel it, and you can see it. And specifically, what shape is a magnetic field around a bar magnet, such as this one? At school we have a lot bigger ones. But first of all, we need to talk about what a magnetic field actually is. Otherwise it won't really make much sense. Okay, it's not a big region of grass where magnets grow or anything like that. Okay, not that kind of field. But it is the region of space around a magnet whereby something magnetic in that field would feel the force of magnetism. So there is a magnetic field around this magnet here, but you obviously can't see it. And at the moment there's nothing magnetic in it for me to prove it's there. Obviously going back to the fork, as soon as I put the fork in the magnetic field of the magnet, then it can feel the force of magnetism. Okay, that's because there is a magnetic field around this. But how do we know what it looks like? This is... Usually I would get you to do this at school, so we have lots of bar magnets and compasses, but obviously we can't do that. So I'm going to have to make this video, which will actually be very helpful for me in showing people what to do in the future, because not everyone listens to instructions first time. So I'm going to put my bar magnet somewhat in the middle of the page, and I have asked you after this video to do... no, have I asked you to do this? No, ignore me, sorry. So I'm just going to... Again, you would do this in pencil if you had it. Oh no, the nib is actually magnetic, which doesn't help. Okay, I've actually got two flies in here now, I think, which are being very annoying. So that you can see that is that's where the magnet was once I've done with this whole activity. And obviously you can't always keep a magnet in your book, and so on, you have to take it away, but putting that back where it was. Now you can use iron filings to show the shape of a magnetic field. I couldn't find any on Amazon. I mean, I could, but they were all in like small tiny little packs and I'd have to buy hundreds of them, so it's just easier if I do it with a compass. So I've got a small compass here. That being said, if you have younger brothers and sisters, or you might just have some old toys lying around from when you were younger, I think they're called Etch-a-Sketch. So they're like, it's like a big, looks kind of like an iPad, but it's got two like knobs that you can turn, and you could I think you can draw pictures, and then I think you can draw on it, and that's because it's got iron filings in it. Maybe look that up to see what I'm talking about if you have no idea. Now, several places around my bar magnet, I'm just going to put a little dot. So I'm definitely going to do a couple here, and the same over here. This is just to mark out where I'm going to put my compass. What I would do, just a few places around here, and the same around here. So I'm going to start with this dot here. So I'm going to put my compass so that it doesn't matter whether it's the north or south, but the north, hopefully you can see, I think you can just about see, the north is in line with that dot there. Can you see that? Then what I'm going to do is I'm going to make a dot where south is, which is here. Then I'm going to move my compass onto so that the north is on it again. Hopefully you can see the north is lined up with that dot. Doesn't look perfectly lined up actually. That looks a bit better. There we go. North is lined up with a dot, and again I'm going to make a dot where the south is. Then again I'm going to put, can you see that actually what's happening is, oh no, that the north is kind of changing its angle. So hopefully you can see it's kind of made, that's the shape it made. And I would like you to draw it back, follow the line and draw it back to the bar magnet. So that's the first bit that we have. If I do the same, let's do the same on this side with this dot. There we go. The north and the dot is just there. I know you can just about not see it, but it's just there. Make a dot where the south is. Okay, move it again until the north is on that dot. There we go. Make a dot where south is. We'll do it again. Dot where south is. Again, dot where south is. Again, dot where south is. And if I were to put it there, you can see it would end up back there. So this time we've got like that. So let's assume it would go, God, it would really help if I was using a pen that did not have a magnetic nib. So very similar to what was happening on this side. Now if I try this dot here, I don't think it's going to work this well, just by judging, probably because of the size of the actual bar magnet is quite small. If I put, you might have to look for this one instead of me drawing the dots. Look at the shape, I need to not let it go, where the north points as I go along. Can you see? The north and south, again, it's following this same direction here. So that would follow here. Let's try this one then. Putting north on the dot. This one's a bit further away, so I might actually be able to do it. Dot by south. Dot by south. And that would go around there again. So it would follow a trajectory like that. Let's try the ends of my bar magnet then. Let's try here. As you can see, it's actually the south. Oh, it's actually south there. North. Oh. It's not going as easy as I hope. It's the tiniest compass I've ever used. North is over there. Let's put south on it again. North there. Put south on the dot. North there. Hopefully you can see it's actually not changing direction. So if I were to keep on going, it would look kind of like that. Now that's not what it would do forever, and I'll talk about that in a minute. But actually, will it? This one kind of looks like it does go on forever. So let's put it over here then instead. So south on the dot, north there, north there, north there. And again, you can see that's continuing. Obviously do it with a straight line. I think you can probably guess what's going to happen here now. It's going to go like this one, and the same is going to happen on the other side. It's going to go off like that. It's going to go off like that. It's going to go off like that with a ruler, and you're starting to see the shape. Those are the magnetic field lines around this magnet. Again, if I had iron filings, I could sprinkle them on and they would follow. This is the shape that they would make. Now, actually, if I kept on doing this, you would find it would keep going like this. bigger and bigger, bigger. And so you can kind of see why these ones go so far out. Eventually it might kind of curve back round. These ones won't, however. And there you go. So again, I could draw more. I know this off by heart. I hope that I've proved it enough to you using the compass. Like that. So that is the shape of the magnetic field around a bar magnet. We tend to call it a butterfly shaped. Some students seem to think it looks more like a spider, or I suppose, I think it's meant to look like a butterfly because if you put it this way, if this is like the body of the butterfly and then you've got its antennae and its wings and things like that, it doesn't really matter what you call it, as long as you remember that's the shape that it is. And that's all you need to know for this lesson. Next lesson we will talk about the direction of the field lines because they go in a particular direction and what it means when certain lines are closer together, as you can see here, compared to when they're further apart, like here. Have a good day.